Hello everyone, my name is Tanuja Khan, Assistant Professor, Department of Education, BSSS College. In the previous videos, we have discussed about analysis of variance. Analysis of variance is basically used to find out the difference between the means when the data is normal, and analysis of variance is a parametric test. In this video, we are going to cover Kruskal Wallis test, that is the alternate of analysis of variance in non-parametric test. So, to find out the mean difference between two or more than two variables, if your data is normal, you go for parametric test, that is analysis of variance. But if your data is not normal, then in that case, if you want to find out the mean difference between more than two variables, you have to use Kruskal Wallis test. So Kruskal Wallis is an alternative test of analysis of variance. It is also known as analysis of variance using ranks. Now the introduction of Kruskal Wallis test. Kruskal Wallis is a non-parametric test and it is a replacement of analysis of variance. It is generally used when the measurement variables does not meet the normality assumption of one-way Anova. That means if your data is not normally distributed, in that case, you follow Kruskal Wallis test in place of one-way Anova. It is also a popular non-parametric test to compare the outcome among three or more independent unmatched group. The next is assumptions. Now, assumptions for Kruskal Wallis test. First is all samples are randomly drawn from respective population. The second assumption is independence within each sample. The third assumption is mutual independence among the various samples, and the last one, your data is at least follow the ordinal scale. Now the working rule for Kruskal Wallis test is all the observation in K samples are combined and ranked from lowest to highest. The lowest observation is assigned as mark 1 or rank 1, or the second observation is assigned as rank 2, and so on. The second working rule is the sum of ranks of all the samples is then obtained, which are denoted by S1, S2, Sk respectively. Now the third step is to square all the S. The fourth one is to compute by the formula. It is also denoted by H, so here we are going to calculate H from the formula. And the formula for H is 12 by n plus 1, under bracket S1 square divided by n1 square, S2 square divided by n2 square, and so on, minus 3 n plus 1, where n is the number of items. N is the number of items in entire data. Now next step is if each n is greater than or equal to 5, the distribution of H is a chi-square distribution with k minus 1 degree of freedom. Hence, consult the critical value of chi-square table at 5% or 1% level of significance. So for Kruskal Wallis test, we will use chi-square table to draw interpretation. So if your H value is smaller than the table value of chi-square, your null hypothesis is not rejected, and if your H value is greater than or equal to the table of chi-square, then your null hypothesis is rejected. Here H0 is denoted for the null hypothesis. Let us discuss one illustration for the same. Analysis the following data by technique of analysis of variance using ranks. Now using ranks, that means Kruskal Wallis test. Now we have three groups, group number 1, group number 2 and group number 3, and we have some observations for each group. For this chi-square value for degree of freedom 2 is 5.99 at 5% level of significance. That means we have to check our null hypothesis at 5% level of significance. Now for the same problem, our null hypothesis is mean of three population are equal. Next is the test computation, we have to calculate H with the help of the formula, and we have all the values. We have N1, N2 and the N. N1 is the number of items in first group, that is 5. N2 is the number of item in second group, that is 8, and N3 is the number of values in third group, that is 6. And here N is, the capital N is the sum total of all the items, that is 19. Now to find out S1, S2 and S3, we have to find out the ranks of the observation. We have three groups, group number 1, group number 2 and group number 3. Now we have to assign rank accordingly. Now in all the data, we have the smallest value, that is 21 in third group. So we have assigned first rank for 21. Now similarly, we have 29 is the second value. So we have assigned second rank. Similarly, we have assigned all the ranks. If in case you have two observations same, like we have 35 here and we also have 35 in third group, then in that case rank of this 35 and this 35, we have to find out the mean rank. Like for example, 35, both the 35s are placed in 10th rank and 11th rank. So in that case, we have to find out the mean of rank, that is 10 plus 11 divided by 2. This is 10.5. So we have assigned 10.5 here and here also. After all the ranks, we have to total group wise, like ranks in group number 1. So we denoted is S1. The total of group 1 rank, the total of group 2 rank is S2, and the total of group 3 rank is S3. Now we have the value of S1, S2 and S3. Now this is the formula to find out H. Now we have all the values. We have S1, we have S2, we have S3. Our S1 is 34, our S2 is 105 and our S3 is 51. We also have N, that is 19. So all these values put in this formula. So 12 divided by N is 19. So 19 plus 1. S1 is 34. So 34 square divided by 5, where N1 is the number of items in group number 1 and N2 is the number of items group number 2 and N3 is the number of items in group number 3. So we have 5, 8 and 6 respectively. So 34 square divided by N1, that is 5. S2 is 105, so 105 square divided by N2 is 8, and S3 is 51 square divided by number of item, that is N3, 6. Minus 3, N plus 1, that means 19 plus 1. So 19 multiplied by 20, because 19 plus 1 is 20, so 20 multiplied by 19 is 95. Square of 34 is 1156, square of 105 is 11025 and the square of 51 is 2601. So after dividing these numbers, we have 231.2, we have 1378.125 and 433.5. Now the final we have 3 by 95, 2042.825 minus 60. And after calculating this portion, we have now 64.51 minus 60 and our H value is now 4.51. Now what this 4.51 talks about? This is our calculated value. And we know that if our calculated value is greater than the table value, that is chi-squared value. In Kruskal Wallis test, we use chi-square table. So if our calculated value is greater than the table value of chi-square, then automatically our null hypothesis is rejected. So let's see. Since our calculated value is 4.51 and which is less than the critical value, that is 5.991. So in this case, our null hypothesis is not rejected because it's a thumb rule that if your calculated value is less than the table value, your null hypothesis is not rejected. So therefore, the mean of three populations are equal. Thank you.